Hi everyone. Today we'll tie a nice little bow around some information that we've already learned about in the mole unit, and we are going to do some conversions using this unit of the mole. So let's talk about some stuff we already know, right? So we know that this unit of the mole allows us to basically convert between mass and number of things. We know that we have this certain number, it's called Avogadro's number. It happens to be 6.02 times 10 to the 23rd power, right? So we know we have that number of particles in a mole of anything. And remember that a particle can have multiple names, right? It can be called an atom if we're dealing with a single element. It's an ion for an ionic, or for a single ion, a molecule for a covalent compound, or a formula unit for an ionic compound. So we'll label appropriately as we go through here today. So we know that we could convert directly between particles and moles, between particles here and moles, using this number, right? And we also know that if we want to do something where we convert between moles and mass, we use something called the molar mass. Remember, the molar mass comes from the periodic table. It's different for each element. For instance, for carbon, it is 12.01 grams per mole. So if we wanted to convert between the number of moles and mass, we could use this number from the periodic table. But what if we wanted to know the number of carbon atoms in a certain mass of carbon? Then we'd have to do two different things. We'd have to bring the mass into play to convert between grams and moles, and we'd have to bring Avogadro's number into play to convert between moles and particles. So let's get some practice with that today. Remember when we use dimensional analysis. Dimensional analysis will never steer you wrong as long as you allow your units to cancel and the top and bottom of your conversions are true. So let's start with the numbers that we're given. And number one, we are given this number 1.204 times 10 to the 24th atoms. So 1.204 times 10 to the 24th atoms of lithium. So I'm just going to call it Li atoms. And we want to know how many moles that is. So question is, do we know how many particles are in a mole? And we do, right? We know that we can get from atoms directly to moles using Avogadro's number. So in 1 mole of anything, there are 6.02 times 10 to the 23rd power, and in this case, that is atoms of lithium. So if you do this math, slide over here, if you do this math, you will end up with 1.999 moles. You'll notice a few things. You'll notice that our units canceled, so lithium atoms went away. You'll also notice that we started with 3 sig figs, we started with 4 sig figs, we end with 4 sig figs, so we're good to go. Looking at number 2, we know we're starting with 388.2 grams of iron. 388.2 grams of iron, which is Fe. We want to know how many moles that is. If you look to the periodic table, do you have a way of getting between grams and moles? You do. It's the molar mass. So you know in 1 mole of iron, it has a mass of 55.85. That's simply the number beneath iron on the periodic table. If you do that math, you will figure out that you have 6.951 moles of iron in that mass. You'll notice here that our units cancel, grams of iron canceled out, and we started with 4 sig figs, we ended with 4 sig figs. So we're doing well thus far. Let's look at number 3. We are given 25.0 grams of sulfuric acid. So let's start with that 25.0 grams of sulfuric acid, which is H2SO4. And we would like to know how many molecules that is. So we know that grams of sulfuric acid needs to go on the bottom, grams of H2SO4. That means moles of let's take a time out here. That means we need to get to molecules on top. And so the question is, do we have a conversion that goes directly from grams to molecules? In other words, do we know how heavy a single molecule is? And the answer is no, we don't. We don't have that information. all we are able to do is tell the number of grams in one, not molecule, but in 1 mole of sulfuric acid, right? So how do we do that? Well, we find the molar mass. Sulfuric acid has many atoms in it, so we have a little bit of work to do, right? We need to talk about H2SO4. H2SO4 has 2 H's. Each one weighs in at 1.01. It has 1 sulfur. Sulfur has a molar mass of 32.07. It has 4 oxygens. Each oxygen weighs in at 16.00. So that gives you 64.00 from oxygen. If you add all of that together, you will get 98.09 grams per mole for H2SO4. So we can plug that in here. We know that for H2SO4, it is 98.09 grams for every 1 mole. This was a good move because grams of H2SO4 cancel. Let's see where we can go next. We want to know molecules. We're currently in moles. We know how many, we know what unit should go down here. We know that moles of H2SO4 needs to go on the bottom in order to cancel. We are ultimately trying to get to molecules on top. Molecules H2SO4. And do we know how many molecules are in a mole? Of course we do. We know that there are 6.02 times 10 to the 23rd things in a mole. Much like there are 12 things in a dozen, there are that many things in a mole. Now our moles cancel. Sorry, this was in 1 mole. If we do the math, multiply the tops, divide by the bottoms, we will get 1.53 times 10 to the 23rd molecules in that sample of H2SO4 in those 25 grams. So that's a lot of molecules, as you know. All right, let's try number 4. We're going to start out with our 6.60 grams of ammonium sulfate. 6.60 grams of ammonium sulfate, which would be NH4 2 SO4, right? NH4 is a +1, SO4 is a -2. And we would like to know how many moles are in that number of grams. So if we want to know how many moles, let's again do the steps that we know. We know that grams is going to have to go to the bottom. Ultimately, our goal is to get to moles. The question is, do we know how many grams of ammonium sulfate, NH4 SO4 is in or are in 1 mole? And the answer to that is yes. That information comes from the periodic table, right? So if we get the number off the periodic table to go in here, that's the number of grams per mole. So basically we're doing the same thing as we did up here in purple, but this time for NH4 SO4. And in the interest of time, I already did this earlier, so I can tell you that that molar mass is in 1 mole, 132.17 grams. But if you'd like to pause the video and try calculating that molar mass on your own, I definitely encourage you to do that. And now this is a good thing because our grams cancel. We have arrived at moles, which is the unit that we're after, the unit we're interested in. And when we do that math, we will get 0.0499 moles. So again, we're using the techniques that we have. We know how to get between mass and moles using the periodic table. We know moles to particles using Avogadro's number. Let's put those in play with number 5. We have 6.25 moles of copper 2 nitrate. 6.25 moles. Of copper 2 nitrate, which is CuNO3 2. We are interested in the mass. So we know some things, right? We know automatically what has to go in the bottom of the next line. We're already in moles, so we know that moles of CuNO3 2 needs to go in the bottom. We're ultimately trying to find mass. We're trying to get to grams. Do we know how to get from grams to moles? We do, of course. We know that the mass of this compound from the periodic table is the number of grams in 1 mole of that compound. So in 1 mole, we need to calculate a molar mass. Again, I encourage you to try this on your own. I happen to already do it. It ends up being 187.57 grams per mole. But again, all I did to get that was the same thing as what I did up here for sulfuric acid, right? I just added together the masses of each individual element. And when you do that, you will end up with a final answer of 1,170 grams of copper 2 nitrate. And you'll notice that our units cancel. You'll also notice that we started with 3 sig figs and we're ending with 3 sig figs. Finally, looking down to number 6, we've got a big one. So we want to know formula units. We want to know particles in a mass. So if we're going from mass to particles, you know this might take multiple steps. Also, we are given 4.5 kilograms of calcium hydroxide, just to make life interesting. Right, so we're going to start out with our 4.5 kilograms of calcium hydroxide, CaOH2. We're on a journey to formula units. Let's see what steps we need to get there. Well, first off, we know that kilograms of calcium hydroxide has to go in the bottom, right? Why does it have to go down there? Because it must cancel out. So kilograms CaOH2 must go in the bottom. We also know that we eventually want to get to formula unit. So do we know how many kilograms a formula unit weighs? Definitely not, right? Formula units, that's like the size of a single compound. We don't know how much a single one of those weighs, but we might be able to get closer by having a smaller unit of mass, which would be grams, and we also know there's a relationship between grams and moles. So let's go ahead and let's do that conversion to grams. We know that there are 1,000 grams of calcium hydroxide in 1 kilogram. And furthermore, once we've done that, we know that grams of calcium hydroxide must go on the bottom. And again, we're on a journey to formula units. So do we know how many formula units there are in 1 gram? No, we don't know how heavy a single atom or a single formula unit is. What we know is how heavy a mole is. So we're going to put moles on top. Moles of calcium hydroxide. And we know that it has a molar mass. Again, this value comes from the periodic table. You could go through and show your work. In fact, I encourage you to do that, but I've done this earlier, so in the interest of time, I will tell you that the molar mass of calcium hydroxide is 74.10. Again, that comes from adding up the number of calciums, 2 oxygens, 2 hydrogens. We now have moles of calcium hydroxide on top. That means moles of calcium hydroxide has to go on the bottom. We ultimately are trying to get to formula units of calcium hydroxide. Do we know how many formula units or things are in a mole? Of course we do. We know there are 6.02 times 10 to the 23rd power things in 1 mole. Once we've done all of that, you'll notice that our kilograms cancel, our grams cancel, our moles cancel. We're left with formula units, which is what we wanted to be left with at the end of the day. If we do this math, we will get 3.7 times 10 to the 25th power formula units of calcium hydroxide, OH2, pardon me. And you'll notice that we have 2 sig figs, because we started the problem with 2 sig figs right there. So just to kind of wrap up and summarize, notice that we have 2 main things that we're able to do. We can go between grams and moles, we can go between moles and particles. We cannot go directly from particles to grams, right? If I tried to do this jump from particles directly to grams, that can't happen. You have to go through moles on your way in between. But other than that, we're just doing our normal conversions. We're using dimensional analysis. We're ensuring that our units cancel. We're showing that the top and bottom of every fraction is equal, and we're solving with the appropriate sig figs.